Saxon Algebra 1, lesson 104. We are officially at the end of the second week after spring break. We are 1/3 of the way to summer. I mean, I'm kind of rounding up because we have to then review and take the final. But anyway, we're 1/3 of the way through the lessons. And I'm chuffed. Okay, last time we talked about the difference between expressions and equations. Equations have equal signs. That's a good tip. And they say solve. And when we have fractions in our equations, that's what rational means, fractions. When we have fractions in our equations, we can eliminate the denominators completely. Hallelujah. We can blow them up and make them go away. And that's good news. This is what we were doing last time, remember? Abstract means we're not going to have many numbers. It's going to be mostly letters, okay? And that, it doesn't really complicate things much at all, you guys. In some ways, it's easier because we just stay with the alphabet and it's fine. So let me show you what the problems look like. All the rules are the same. The process is the same. Here's what's different. Let me just show you what the problem looks like. Okay, that's kind of cute, right? And remember last time how I talked about that we have to make sure that we say that x doesn't equal 0 and m doesn't equal 0 because that would blow up the kingdom and we can't have it. John is now making this part of the problem. He's writing as part of the problem, x and m do not equal 0. He's taking care of that for us now. We don't have to put that as part of the solution because he's making it part of the problem to say, don't worry, I won't let those blow up. Now, here's what's tricky. In the old problems, we knew that we were trying to, here, let me just show you one. Oh, there's such a mess, you can't really tell. We only had one variable and the rest were numbers in these problems. And we were trying to work down to a point of like n equals 2, right? Well, we don't have numbers in this problem. I mean, there's just a 1, but that's not really going to do anything. And we have lots of letters. That's the real problem, is we have multiple letters. How do we know which one to solve for? And here's the thing. Based on this information, we don't. We don't know, should we solve for x or b or m or c? I don't know, but we rely on John because he tells us. He writes in his instructions, find m. So that gives us direction. We're trying to get the m by itself and everything else shoved to the other side. Okay, now we have a mission and a mandate. We're to go to the Mars and we're going to land on Mars. So now that gives us a way to proceed. What we do though is pretty much always the same. First step, blow up the denominators. Anytime we have a rational equation, that's pretty much our first step. Let's get rid of them. I don't want them in there. So we find the LCM, and it's super easy with letters. We know we have to multiply because least common multiple reminds us. X times m. I'm going to write it alphabetically. And then we have to multiply every term. That's the only downside of this, is we have to multiply every term whether we want it or not. This one doesn't even have a denominator, but we have to multiply every term in order for things to stay in balance. We cross out, so this first one will just become m, right, because it's 1 times m. I just turned the 1 into an m. Here the m's cancel, so this will be bx, and then there's nothing to cancel against that, so all of those parts will go. So now we have m plus bx equals cmx. Okay. Now, we are ready to, this is the way I see it. Let me write it and then I'll explain it. Gather the desired letter, I'll put the, on one side. Our desired letter is M. That means every term that has an M in it needs to be on one side of the equal sign. It doesn't matter which. We can do it however we want. honestly, do whatever's the fastest. But that's our next step. So I look at this, I go, okay, this one's got an M and this one's got an M. One's going to have to swim to the other. But if I move him over here, then I don't have to move the BX. So I'm going to do that. BX equals CMX minus M. Third step. Factor out the desired letter. Okay, so that's all going to be on this side. I'm going to leave the BX equals the same. M is my desired letter. So I'm going to factor that out of this pair of terms. I'll be left with CX, and here comes the tricky part. When we factor the M out, this isn't 0, it's 1. And the way you can test that is, now let's see if we can distribute back and get what the original thing is. M times CX would be CMX. M times 1 would be M. It works. All right, we're almost done. Fourth step. Divide away the mess. What I mean by that is, this is our desired variable. This is the mess, right? So we'll just divide this by CX minus 1. Right? This cancels. And now we get, and usually I have a shortcut that prevents us from having to rewrite every time. But it's not really working this time. All right? M equals BX over CX minus 1. Now, this is right. John's looks slightly different, though, because he wrote XB instead of BX. I always prefer alphabetical. I almost always go alphabetical, and John doesn't. When we're multiplying, which is what this represents, the two letters together, when we're multiplying, order does not matter. So BX and XB are twinsies. All right, and then the last thing that we really should say, similar to this, is we also have to say that CX minus 1 doesn't equal 0. Right? Because we got to protect that as well. So whenever you see letters in the denominator, just be careful. But basically, these problems are nice and neat and clean. Okay, there's 2 more. Let's do them. I'm having fun. Are you? I can just see your faces. Find B is the instruction. So I don't write find B, but I do write down the letter and circle it because it helps me remember what the heck I'm doing. Because it's easy to get lost in these because it's just alphabet soup. Have you guys ever actually eaten alphabet soup? When I was little, I thought that would just be, and I mean little, like, 5. I thought it would be so cool to have alphabet soup and to, TV commercials used to show, you dip your spoon into the soup and get a word, of the letters would all line up on your spoon and you would have this cool word. And I thought that was so amazing and I really wanted to try it. Well, my mom finally bought me a can of alphabet soup and the noodles were all broken and they do not come out in perfect words and you get weird broken shapes and it was extremely disappointing to me. So alphabet soup, I'm like, that's like unicorns and pixies. Real alphabet soup doesn't exist. I'm a little jaded. Okay, we're on number 2. We're supposed to find B, and we're told that B and D equal not 0. I like to write that down because it's a good reminder to me that I should do that at the end, right? And say what the denominators that can't equal 0. Okay. Same steps as before. Number 1, blow up the denominators. Use the LCM to do it. I always like to write down my LCM. It's just BD. So easy, right? So we're going to multiply. That's because we haven't got any. John's not going to give us any binomials yet. Okay, so we're multiplying all of those. If that looks weird to you and you want to put the parentheses around, that's fine. It's just one more thing to write. Here the B's cancel and we get AD. Here the D's cancel and we get BC. See how I'm just keeping them alphabetical? And here nothing cancels, so it's going to be BDX. Okay, now I'm going to rewrite that so it's not a hot mess. gather up our desired variable. That's why I like to have this here, because by now I've forgotten the desired variable. I got so busy with this. B is what I want. Okay, so there's a B and there's a B. I'm going to subtract the BC. And I'm going to get AD equals BDX minus BC. Okay? Grace, are you all right? She's been having a little licking session over there. Okay. I want the B's. There they are. Now I factor them. Here I'm left with DX minus, and there I'm left with C. Right? Once I pull the B out, what's left behind? And then I divide away the mess. And this is a way you can simplify this. DX minus C, DX minus C. This all cancels, and what I do is I rewrite the letter. It says equals B. I just moved it over here, and then I box it like this. I don't want to have to rewrite everything every single time. So that's kind of a shortcut way to just present a neat version of your answer without having to rewrite. And these problems do get fairly complicated letters. John wrote DA over DX minus C. I like mine better. I like alphabetical. Sorry, John. Sometimes I win. No, it's a zero-sum game. It's not a zero-sum game with John. There's no winners and losers. We all win when we hang out with John. 104.3, find X. Oh, we also have to say the answer for this one. We also want to add to that DX minus C does not equal 0. So don't forget that. All right? X. And I thought of it when I went on to the next problem and I saw B and X equals not 0. It's okay. Let that remind you. Oh, yeah, I have to do that too. Okay, here we go. A over B minus C equals D over X. We're looking for X. First step is always the same. Use the LCM to blow up the denominators. It's just BX. That's what I like about the abstract one, you guys. It's just so simple and straightforward. Okay, the B's cancel. We get an X. This one, it's all there, so it's BCX if I go alphabetical. And then this one, the X's cancel, so it's BD. Now I shall rewrite. Okay. X. Oh, look, the X's are already grouped together on the left side. It doesn't matter whether on the left or the right. It's totally fine. Doesn't make any difference. And you can swim them in either direction. There's no rules around that as long as you just gather them up by themselves on one side and shove everybody else on the other side. And by everybody, I mean the other letters. It'll be fine. Factor it out. And then divide away the mess. And if you're neat, you can just do that. That all canceled. And there's my answer. BD over A minus BC. John agrees. Yay. All right. And then we have, and then we have to say also that A minus BC equals not 0. And we don't have to do anything to solve that. We can just leave it just like that. Okay? And I'm going to flip the page. That's too crowded, and I'll just be unhappy. You guys don't want me unhappy. Cranky math teachers are no fun. 104.4. Ready? Find X. And there's no rhyme or reason to the letter that John chooses. He gets just to do whatever he wants. Because that's how John rolls. There we go. And we're also told that X and N do not equal 0, which is a good thing. Our least common multiple, well, we just multiply those dudes together and we get NX going alphabetical. So I'm going to multiply every single term. Okay, we can tell they're terms because they're separated by pluses and minuses, like boxcars in a train. And now let's see what cancels. That becomes an. Oh boy, this has all of it. So it's going to be nxy. Here the n's cancel, so it's mx. And here there's nothing too, so it's knx. Okay, now I'm going to write it all out. an minus nxy plus mx equals knx. Whoops. I was thinking about Knoxville, Tennessee, and I wrote knox. That's not good. Okay. Now we have to get everybody on the same side. Well, I guess what I choose to do is I choose to leave a in there, and I'll kick those guys over. And I'll remember, I'm not going to write it all out. I'm going to remember my rule that if you want to change sides, you have to change signs. So I'm going to start with what I had, and then I'll go through this side. I'm changing the him, so it's going to be plus nxy, and then that'll be minus mx, right? That's the shortcut to swimming fish. Now I will factor that x out of there, and I will get kn plus ny minus m. And now you can see what I mean, how some of these get pretty long and gnarly. And so I want to divide away the mess. That an is kind of down at the end of the numerator, but that's okay. Kn plus ny minus m. Kn plus ny minus m equals x. That all cancels. And hopefully I copied that correctly. John has NA, okay, I have AN, same difference. NK, okay, same, plus NY minus M. Okay, so this term and this term he has in the opposite order. Multiplication doesn't matter for order, so that is fine. Yay. And I can also say that KN plus ny minus m cannot equal 0. Yay. Make sure you're slowly developing that habit of preventing yourself from the kingdom exploding, all right? We cannot have that level of destruction. All right, guess what? That's the end of lesson 104. We're officially done. Yay. Goodbye.